My name is Palayo Silva.
My name is Daniel Petty.
My name's Abraham Cruz.
I'm Brandon Chandler.
And I'm Imad Ahmad. And our topic is urban infrastructure, and we will be going over the cost and distribution analysis. Also, our goal for this project is to restore and improve urban infrastructure. We will be analyzing the data found in the current state of infrastructure, and we'll be able to distinguish the flaws from an engineering point of view. By looking into populations of the cities with respect to freeway and railway miles, and relating that to the transportation statistics, a conclusion can be drawn to improve the American Society of Civil Engineer overall grading for that category of U.S. infrastructure. As mentioned before, our goals to consider is to collect data on the largest populations, gather which transportation systems are used most frequently, have users select city out of the menu function and output the data, determine how the total budget should be distributed towards the roadways, bridges, and rail system, calculate which cities are in most need of infrastructure improvements.
Alright, for our code, our main functions we use were if statements, while loops, for loops, and menus, and plots. We started our code by setting two variables, ex as a counter variable and start as a while loop condition. We created the while loop to check if the user would like to repeat the code for a different city, and we only made them repeat once. We use a load data to load our dataset for this whole code. From that dataset, we extracted a vector for the city's names, a vector for the state names, and a vector for the fare revenue. We also got the user to input a city they would like to use to evaluate all of the conditions we made. From there, we extracted the public transit percent from the dataset, the walk percent, no, travel to work walk percent from the dataset, travel to work bicycle percent, and travel to work from home percent. And we also data validated the whole dataset to make sure that all the numbers were positive. If not, we will take the absolute value of that negative number. And then from there, we created a vector for the travel to work or work at home data for the user selected city.
Using the calculations, we're able to output graphs and pie charts from our user selections and our internal calculations. The first step is we went ahead and summed the percentages for each type of public transportation. This gave us our percentage for the walking, biking, and working at home. We then created a vector that has a percentage for each type. This will be transposed to a cost revenue vector later in our code. We changed that cell array for the city names to a string vector. This was able to let us create a legend with each type of data, as well as use it in our sprintf statement for our pie chart and our bar graph. And these were based off of the user inputted city, whether they wanted to input one or two cities. Once our bar graph was created and our legend was finished, we found the difference in revenue for each type of data, the bicycle, walking, and working at home. And then we asked the user if they would like to compare the results to another city. We repeated the code using our while loop from the beginning and outputted the results of the second city and the first city into a graph. The code was only repeated once to compare two cities, and then we outputted the total revenue for the city and the difference in revenue, if applicable. And then we exported the results to the command window with each of their total revenues.
For the test cases, we had Houston and Dallas, and we have the graph breakdown of public transport, walking, bicycle, and as well as the people that work at home. And we break it down into the percentages, and that way you can, if you choose two graphs of Houston or Dallas, if you wanted to do a comparison graph, you can choose and look at which methods of transportation are the most used in the city. Or if the user just wants to look at one city, then they can select one, and you pull up one figure that will show you the breakdown for the public transportation, the walking, the bicycle, and as well as they work at home. And for the third figure, if you do a comparison of between two different cities, you'll get how much each city makes in terms of revenue, and based on the revenue breakdown, how much money should be used towards each method of transportation, excluding working at home. So the x-axis is just the amount for biking, public, and walking, and then the y-axis is just referring to how much money should be spent into each of those modes of transportation for each city, based on how many people take that method of transportation. And so for our output from our fprintf statements from the code, it tells you how much revenue is generated for each city if you do a comparison between two figures. So for Houston, for example, it would be 57 tens of million, and for Dallas it is 47 tens of million. And the difference in the public transportation revenue is 69 tens of millions of dollars, and then same for walking transportation revenue and biking transportation revenue. They all have a difference of however much between the difference between the two selected figures.
In conclusion, the user is able to draw a data set from the Victoria Transport Policy Institute that shows information on major U.S. cities and their transportation system and populations. The user is able to identify the city's percentages of populations and output a pie chart showing each individual usage, such as bike usage, public transport usage, and walking usage. The code also outputs total fare revenue, operating expenses, cost recovery ratios, and the user is able to identify where resources should be proportionately allocated to meet the city's demands, and also compare these statistics in money to another city. The limitations of this code is only 2 cities can be compared at one time. There's no data on where resources are actually spent and accounted for, and other variables may need to be taken into account besides the population usage when thinking about where to allocate the resources for public transport.